And for our final review question of the day, we have an unstable nucleus of an element decays by emitting an alpha particle or a beta minus particle to become a nucleus of a different element. The nucleus is also unstable and also emits an alpha particle or a beta particle. The process continues until an isotope of the original element is produced. What is the minimum possible number of these particles emitted? Well, I like this question because you really have a fun puzzle that you get to solve there. And the clock is ticking. We've got about 3 minutes. Let's try to make the best sense of it that we can. So we know it's going to emit either an alpha or a beta particle, a beta minus particle. Both of those are going to change this nucleus, right? So it's either going to go down by 2 protons, or it's going to go up by 1. Because remember, when we eject a beta minus particle, a neutron has transmuted into a proton, so the atomic number goes up. So, you know, we sort of go down by 2, or we go down by 1 in terms of the proton number. So to be an isotope, remember, we have to have the same atomic number, the same number of protons. It could be a different mass, but it has to be the same element of the original element. So the minimum number, like what can we do that's sort of the smallest thing? So remember, this is going to actually bump us up 1, right? So the beta minus particle bumps us up on the periodic table because we're kicking out a negative, and so the neutron became a proton. So these ones bring us down 2, these bring us up 1. So that kind of suggests that 3 is the minimum possible number, right? Because we emit a alpha particle to go down by 2, or you emit 2 beta minus particles to go up 2, and then you've got to, you know, cancel it back out by ejecting one of these. And so it's just like the charge on an alpha particle is +2. So when you emit an alpha particle, you're sort of going down by 2, right? It's like the charge on an alpha particle is this. And so when it's ejected, you go down by 2 on the atomic number, which would require 2 more beta minus decays to bring you back up to the original isotope. That would be sort of the most straightforward path to achieve that. 3 would be the minimum number of those reactions. And it would go, you know, alpha, beta minus, and then you'd be back there again. Your mass would be down by 4, but you'd be an isotope. Or it could happen the other way, 2 beta minus decays and then an alpha decay. Either way, you're an isotope of the original element. Have a good day, everybody.